Happy New Year, and I hope you had a wonderful holiday period. Welcome, guys, to EDU Solutions Institute. Now, last semester, last term, we focused a lot on our IB syllabus, and this term we're going to do the same. So stay tuned as we explore more on our IB physics syllabus. Our last session, we focused on the calculations of energy work power. Now, in this semester, we will be focusing on our first HL topic, right? So our first higher level learning, we'll be focusing on that topic from our new syllabus revised. Now, this topic has to do with moment of inertia and torque. So in today's lesson, we'll be looking mostly on the basis of rotational objects. And then next week into the other weeks, we'll be focusing in depth in terms of calculations and a lot more equations that we will use. So stay tuned as we explore this topic to the widest possible outcome. Now, the term moments of inertia, what exactly does that mean? Moments of inertia has to do with the resisting ability of objects when they are rotating. So if we have a wheel that is rotating, let's say a car wheel that's rotating on the ground, then the natural ability of the wheel to resist acceleration in terms of that rotation is known as moment of inertia, right? Now, moment of inertia is represented by the letter capital I, and it is the sum of all the masses that is being rotated about that specific axis. So in moments of inertia, we have to focus on the axis of rotation. And the axis of rotation is basically that imaginary line that is drawn through the point where the object is rotating about. So for a wheel, it would be through the points where the lugs are that connects the wheel to the car, right? So that is our draw a line through there, and that would be our axis of rotation. Now, so all the masses of this wheel, the sum of all the masses, right, times r squared. And r squared has to do with, if we take this point as our rotational axis, then if we look at this mass right here, it is that r away from the axis of rotation. If we take another mass here, it is also r. It's a different r, so we can call this r1 and this is r2. So therefore, if we use this mass times its r squared plus this mass times its r squared, all different masses in the object rotating about this axis, if we find their product of mass and r squared, then what we're finding is the overall moment of inertia of that specific rotating object. Now, based on that, the unit for I is kilogram for the mass and meter squared for multiplying by r squared. Now, in terms of rotational objects, we also look at a term called torque. And torque is the same as moments, right? So both terms can be interchanged in terms of their use. They mean the same. But in this level, we normally talk about torque because we don't want to mix it with momentum if we say moments. So to make it clarify, we will stick with the term torque. And the torque is an effect of objects turning due to a force. So example, if we look at the same wheel that's rotating, it is turning about the point of axis, and that is due to a force. So therefore, the effect of that force and the distance that it is away, right, will give us the torque. And torque is represented by our Greek symbol here, T, and we multiply the force that is being applied to cause the rotation times the distance away from the pivot point. So if you look at this object, if this is your pivot point here, this is the point where the object is going to be rotated about, then if the force is being applied here, then this distance right here is your R, right? So it's the value of the force times R, and notice here we have sine theta. What's the purpose of the sine theta? Now, the sine theta, it is due to the fact that this force is not acting 90 degrees to the distance R. So in order to get this force to act in 90 degrees, we have to find the basic y component of the force, and that would be opposite to the angle, and that's why we have sine there. But please note, if by any chance, instead of having that angle, we had this angle beta, it would be different, because beta now would be, if we get it to 90 degrees, we would need this point, which is Fy here. And that Fy would be F cos theta, because now it is adjacent to the angle beta, right? So please note, this formula can change based on the angle that you have. So you have to look in terms of the angle to ensure that if you have this angle, you use beta, you use cos, or you would find this angle to use sine, right? But you have to key in looking on what it is. Now, we can link torque, because objects rotating about an axis can be linked to resisting acceleration, which is moment of inertia. So if we link torque with moment of inertia, then it is multiplied by a constant of angular acceleration, which we use as the sigma sign here. Now, this value would be explored in our future lessons, where we look at how do we find our angular acceleration and what is angular acceleration. But for today, just to make the link between both quantities, is that to say that the torque of an object is equal to its moment of inertia times the angular acceleration. Because once the object is moving, it is going to rotate, it is going to have an acceleration. Its ability to try to not have acceleration is what we call moment of inertia. So before we go, just a recap that moment of inertia is the ability of objects to try to not accelerate while rotating. But it's impossible, right? So it's impossible to not accelerate while rotating, but naturally objects will tend to want to do that. And we can find that value by multiplying the mass times the distance away from the rotational axis squared. And then we look at torque, which torque is basically the effect of objects rotating or moving about a unique point. And that torque is equal to the force that's being applied times R, which is the distance from the pivot point of rotation or the axis of rotation to the force, times sine theta if we have the angle between the force and R, or cos theta, cos the angle if we have the opposite angle. So that's the lesson for today. Hope you understand a little bit more on the moment of inertia and torque. And I'll see you next week. Please stay tuned to more on IB Physics Syllabus here at EDU Solutions Institute. Bye-bye.